Okay, so matrices and system of equation. In previous two section, we solved system of equation using substitution, elimination, and graphing method. In one of the section, we discussed about how to solve system of equation in three variables. Here, we're going to introduce matrix, and then we're going to use matrix to solve system of equation. That's the goal. So this is, let's say, one of the example is this is one system of equation. We can write down this system using only the coefficient of the variable and constant. So the coefficient of x is 2, coefficient of y is -3, and then constant on the other side of the equation is 7. So this first row is coming from the first equation. The second row is coming from the second equation, and then this form, this thing is called a matrix. These vertical lines are the columns, the horizontal lines are rows, and this vertical line separates the left side and right side. So what is a matrix? A rectangular array of number is called a matrix. In augmented matrix means for the given system of equation, it contains not only the coefficient but also the constant terms. Okay, this matrix is called coefficient matrix. This is the coefficient matrix. And augmented matrix means you have to include the constant slash this, this vertical line, and then the constant term. So this is an example of matrix. This line, horizontal line, they are called rows. Vertical lines are called columns. And then depending on how many rows and how many columns you have, you can find out the size of the matrix. For example, in this case, there are 2 rows and 3 columns. So the size of this matrix is 2 by 3. Okay, so we represent size of the matrix by m by n. M is number of rows and n is number of columns. Whenever you have rows and columns are equal, that type of matrix is called square matrix. We use Gaussian elimination process to solve system of equation in matrix. What does that mean? We are allowed to, in that elimination process, we are allowed to interchange any rows. We're allowed to multiply each entry in a row by the same non-zero constant. We're allowed to add a non-zero multiple of one row to another row. So these 3 operations are allowed in this Gaussian elimination process or row operation. We can use this operation on an augmented matrix to solve system of equation. So how do you do that? Let's say we have an augmented matrix. We try to change that into row echelon form. So for example, let's say if you're talking about 3 by 4 matrix, then row echelon form means the first row supposed to be start with the 1, and then everything else supposed to be 0 on the left side of the equation, and on the right side we don't care. And then right after that, the second row supposed to have 0 and then 1, and then everything else after 1 is 0. We don't care about the right side. And third row is supposed to be 0 0 and then 1, and then everything else on the other side we don't care. So if you are dealing with a 3 by 4 matrix, then this is the row echelon form. So in general, if a row does not consist entirely of zeros, then the first non-zero element in a row is supposed to be 1, the leading. For any 2 successive non-zero rows, the leading one in the lower row is farther to the right. Look at here. This one is farther to the right. Okay? All the rows consisting entirely of zeros are at the bottom of the matrix. If a fourth property is also satisfied, a matrix is said to be row reduced row echelon form. So whenever you have this form, it's easy to solve a system of equation. So this, there are some special system where before solving you have to be careful. For example, this system, as you can see here, all the elements, all the entries are 0 here. That means this system has only 2 equation but 3 variable. Because of that, the solution is supposed to be dependent. That means your solution is supposed to be in terms of one of the variables. So for example, in this case, x can be expressed as a z and y can be expressed as a z. So the solution is supposed to be infinite solution like this. Sometime you might have a row like this, where on the left side of the equation there is a 0 and on the right side of the equation there is a 9. So it means 0 equal 9, which is false statement. That means there is no solution of this type of system. They are a special system. Okay, now let's look at some examples. Let's go here. Write an augmented matrix. Augmented matrix means just use coefficient. So from the first one, it's a -4, +8, and other side of the equation is 2, +3, -4, and other side of the equation is 1. That is the augmented matrix. That is also augmented matrix, so I'm going to skip that. So from the augmented matrix, we would like to write down equation. So 4x minus 2y equal 6. That is the other side of the equation. Similarly, 2x plus 3y is equal to -6. That's coming from the second row. We can write down the equation, no problem. Solve the following system of equation using the Gaussian or Gauss-Jordan elimination process. So I'm going to show you how to do this type of problem. So first of all, we try to write down the equation in augmented form. So the coefficient of the x in the first equation is -15. Coefficient of y is -3. Coefficient of x is 6. Coefficient of y is 1. And then other side of the equation there is a -63 and there is a 26. Keep in mind, to solve this equation using this process, you need to change it into the row echelon form because it's a 2 by 3 equation. So that form is supposed to be 1 0 and 0 1 on the left side, and on the right side we don't care. That depends on what values you are going to get. So we need to make this thing 1. How can we do that? We can divide this equation by -15. So this is the row 1 and this is the row 2. We are only allowed to do the row operation. So what I'm going to do is I'm going to change the row 1 by multiplying the row 1 by -1/15. So by doing that, it would be 1. If I multiply this by -1/15, that would be 1/5, because 3/15 means 1/5. And other side of the equation, just multiply negative and negative is positive. Divide 63 by 15. So if you want to simplify, 63 divided by 15, it's a divisible by 3. It's actually 21 divided by 5. So I'm going to use the simplified version, 21 divided by 5. Okay. Okay. So the second equation is same. There is nothing we have done here. After this, after changing this 1, we go down here and we make this thing 1. 0. How do you do that? You are allowed to do the row operation. So let me just copy it. It's supposed to be 1/5. So it's 1/5. 21 over divided by 5, and then the second one is 6 1 and then 26. Our job is to make this thing 0. So we are going to change row 2. So what we are going to do, row 2 minus 6 times row 1, because 6 minus 6 gives us a 0. So in this case the row 1 is fixed, so just copy the row 1, which is 1 over 5, and then other side is 21 over 5. If you multiply the first one by 6 and then subtract from the second one, it would be 0. So 1 minus, if you multiply 1 over 5th by 6, it would be 6 over 5th, subtract from 1, so that would be 5 minus 6, which is negative 1/5. So that would be negative 1/5. And then 26 minus 6 times 21 divided by 5, which is 5 times this, which is 130 divided by 5 minus 126 divided by 5. So 130 minus 126 is 4 divided by 5. So I'm just, subtracting 6 times row 1 value from row 2 value. Okay, this is 0 and we need to make this 1. That's the row echelon form. So how we can do that? We can multiply the row 2 by negative 5 times row 2. By doing that, on the first row it's a 1/5, and then 21 divided by 5. And the second row, if you multiply this by negative 5, it would be 0. It would be 1, and then this would be negative 4, because negative 5 times 4 over 5 is negative 4. So from here we can see the value of y is negative 4. We also have to make this thing 0. How we can do that? We can multiply the second row by 1/5 and subtract from row 1. So I'm going to copy this in the next page. It's a 1/5, 21 divided by 5, I guess, and then 0, 1, negative 4. We have to make this thing 0. So we want to change the row 1. So we want to multiply the row 2 by 1/5 and then subtract it from row 1. If I do that, so 1 minus 0 times something is 0. It's still 1. 1 over 4 minus 1 over 5 minus 1 over 5 is 0. And there is the calculation you need to do. 21 over 5 minus 1/5 times this. 1/5 times negative 4, which is negative times negative is positive. 21 over 5 plus 4 over 5, which is 25 over 5, which is 5. So here is the 5, and then here is the negative 4. So from here you can say, if you convert this augmented matrix into the equation form, from the second equation y is negative 4, and from the first equation x is positive 5. So 5, negative 4 is the answer. There is only one solution, and that is 5, negative 4, and that's what we found using the that Gauss elimination process. We can use the same thing here. Okay, let's do one more problem in 3 variables. So I'm going to make this, I need more pages here. Okay, let me just copy this. The augmented matrix, it's supposed to be 1, negative 3, positive 4, and other side is positive 3. 4, positive 1, negative 1, negative 17. 3, 4, negative 6, negative 24. That's the augmented matrix. Our goal is to convert that into this form: 1 0 0 0 1 0 0 0 1, and on other side whatever you get, that would be your answer for 3 different variables. So when you try to go from this form to this form, always start with the 1, go down, make it 0, go down, make it 0, go this side, make it 1, go down, make it 0, go this side, make it 1. This is the direction you're supposed to take. Okay, so first of all, there is already 1. I just have to make the second one 0, and I can do that by doing this row operation. Row 2 is row 2 minus 4 times row 1. Yeah, because 4 times 1 is 4 and 4 minus 4 is 0. So I'm going to make that changes here. I'm also going to do the same thing for row 3 because I also need this to be 0. So row 3 is row 3 minus 3 times row 1. So the row 1 is fixed, which is 1, negative 3, 4, and then other side is 3. Row 2, 4 minus 4 is 0. I have to do that individually. So 1 minus 4 times negative 3 is actually negative 12. So 1 minus minus becomes plus. 1 plus 12 is 13. Negative 1 minus 16 is negative 17. Negative 17 minus 3 times 4 is 12. That is negative 29. Yeah, that's the second row. And the third row is 3 minus 3 is 0. 4 minus 3 times 3 is plus 9, which is 13. Negative 6 minus 3 times 4, which is 12. So negative 12, negative 18. Okay. Negative 24 minus 9 is negative 33. Good. So 0, 0. Now we have to make this thing 1. How we can do that? By dividing this everything by 13. So let's do that. So change row 2, divide row 2 by 13. By doing that, what happens is the row 1 would be fixed. That's the same thing. Row 2 would be 1, negative 17 over 13, negative 29 over 13. Did I do something wrong here? Let me go back and check. 4, 1, negative 1. This is very time consuming type of problem, and you have to double check every single step because you don't want to make it wrong because it takes a lot of time. So I'll go back. 4, 1, negative 1 and negative 17. So 4 minus 4 is 0. 1 plus 12 is 13. Negative 1 minus 16 is negative 17. Negative 17 minus 12 is negative 29. Similarly, 3 minus 3 is 0. 4 plus 9 is 13. Negative 6 minus 12 is negative 18. Negative 24 minus 9 is negative 33. So that looks right. So if you divide, this is the one you get. Okay. So the third one is same. 0 and then 13 and then negative 18 and then negative 33. I need to copy this value to the next page. I don't know how to copy it. Can I copy this? No. This is the value I would like to copy. This one. No, just this one. Okay, so let me go to the next page. So the values are 1, 3, 1, negative 3, 4, and other side you have 3, 0, 1, negative 17 over 13, and negative 29 over 13, 0, 13, negative 8, negative 18, sorry, and negative 33. So this is the one. After making this 1, make it 0. So how we can do that? Take row 3 and then subtract 13 times 13 times row 2, which is actually this equation. I'm subtracting this from this. So 0 minus 0 is 0, 13 minus 13 is 0, negative 18 minus minus plus 17 is negative 1. So it's a 1, negative 3, 4, 3, 0, 1, negative 17 over 13, negative 29 over 13. If I multiply this by 13, I'm going to get this row. So I'm subtracting row 2 from row 3. So that would be 0, 0, negative 18, positive 17, so negative 1, negative 33, positive 29. That would be negative 4, right? Yeah, negative 4. So there is a negative 1. We don't want negative 1. We want positive 1. So multiply this row 3 by negative 1. And that will give us and I'm going to just copy the rest of the thing. That will give us 4. So this 4 is the answer for Z. But keep in mind, you also have to make this thing 0. So I will go back here, and how do you make this thing 0? Subtract row 3, you need the same thing like here. So 17 over 13. So what I'm going to do is, I'm going to multiply the row 3 by 17 over 13 and then add with the row 2. If I do that, my row 1 would be same, 1, negative 3, 4. And my row 3 would be same, 0, 0, 1, 4. But my row 2 will change 0 plus 0 times 17 over 3, which is still 0. 1 plus 0 times 17 over 3, which is still 1. And, negative 17 over 13 plus 17 over 13 times 1, which is 0. Negative 29 over 13 plus 17 over 13 times 4. 17 over 13 times 4, which is basically 13 here, negative 29 plus 17 times 4 is 68. So which is 39 over 13. And if you divide 39 by 13, which is 3. Okay, so finally, because we have a 0 here, we want to make this thing 0 and this thing 0. How are we going to do that? We can change row 1 by multiplying this thing by 3 and add to row 1. So multiply the row 2 by 3 and add to row 1. That makes this thing 0. And again, multiply the row 3 by 4 and subtract, so multiply this thing by 4, negative 4, which is row 3, and add to row 1. So we can do these two operations simultaneously. So let's finish one thing first, because that's not going to change 1. And then, so let me just do this one thing first. So second and third, it stays same. Nothing will be changed. For the first one, 1. It's not going to change because 3 times 0 or 4 times 0 would be still 0. So this one becomes 0 because 3 times 1 and then this one becomes 0. So this one also becomes 0 because negative 4 times 1 is negative 4 plus 4 is 0. The only change you will see is here 3. 3 plus 3 times, oh, that's supposed to be 2, okay? 3 plus 3 times of 3, which is 9. 9 plus 3 is 12. Now 12 minus 4 times 4, 12, and then 4 times 4 is 16, so minus 16, which is negative 4. So these are the answer. I did this calculation here, so from here the x is negative 4, the y is 3, and z is 1. So let me try this one. If it's not right, then I have to come back and check it again. So x is negative 4, y is 3, and then g is 4. I can also check this value here. So that's perfect. That's the answer. I can also verify this answer here before I hit my submit button. Okay. So that's the Gauss elimination process, and we use the row operation to solve system of equation. And that's all for this section.